So here we have the fourth question. A sinusoidal voltage of peak value 285 volt is applied to a series LCR circuit in which R is equal to 5 ohm, L is equal to 28.5 millihenry and capacitance C is equal to 800 microfarad. Find a resonance frequency, calculate the impedance, current and power dissipated at resonance. So dear students, let us first write the data. Here we have R is equal to 5 ohm, L is equal to 28.5 millihenry, means 10 to the power minus 3 henry. Capacitance C is equal to 800 microfarad. So we need to find out resonance frequency, that is F naught is equal to how much. Calculate impedance, current, since it is not mentioned which current it is, so I will take it as RMS value of current only. So then we have to find out the power dissipated in this LCR circuit. So first of all, we have resonant frequency formula, that is 1 divided by 2 pi square root of LC, that is equal to 1 divided by 2 into 3.14 into square root of L is 28.5 into 10 to the power minus 3 into C is 800 into 10 to the power minus 6. And if you solve this, you will get F naught is equal to around 33.35 Hertz. So this is the resonant frequency. Resonant frequency. Next, we need to find out impedance. So impedance formula is R square plus XL minus XC whole square, which is equal to R when at resonance. So Z is equal to R, so that's why at resonance. Okay. Therefore, we'll write Z is equal to R. R value is 5 ohm. So that is the value of impedance. This is impedance. Okay. Next, we need to find out IRMS. IRMS is given by VRMS divided by Z. Is VRMS given? No, V peak value is given. So VRMS is given by V0 by root 2 into Z. So that is equal to V0 is 285. What is root 2 value? 1.414 into Z value is 5. So if you solve this, you will get around 40.3 ampere. That is the RMS value of current. And the last thing is the power dissipated at resonance is given by VRMS into IRMS. VRMS value is V0 by root 2, that is 285 divided by root 2 into IRMS is 40.3. So that is equal to, you will get somewhere around 8122 or 8120 watts. Around this value you will get. So this is very very important for your board examination. Try to practice it. Next we'll move on to the fifth question. That is, a resistor 100 ohm, a pure inductance coil of L is equal to 0.5 Henry, and a capacitance or a capacitor are connected in series in a circuit containing AC source of 200 volts 50 hertz. So 200 volts means it is the RMS value of AC voltage. In the circuit current, in the circuit current is ahead of the voltage by 30 degree. Actually it is if the circuit current is ahead of the voltage by 30 degree, find the value of capacitance. So here we have two circuits. One is inductive circuit, for which XL is greater than XC, and capacitive circuit means XC is greater than XL. Here current is ahead of voltage means current leads the voltage. The hint that we have here is IC, ICE, and ELI. In case of capacitive circuit, current leads the voltage or EMF. In case of inductive circuit, EMF leads the current. So here since the current is ahead of voltage, we can consider it is a capacitive circuit. So by considering that, first let me write the data. That is, we have a resistor of 100 ohm, an inductor of inductance 0.5 Henry, capacitance of the capacitor need to be found, and voltage applied VRMS I will take, that is 200 volts. Frequency is given, which is 50 hertz, and what else is given? Current leads the voltage by 30 degree. Correct? No? By using this, we know that tan phi is equal to XC minus XL by R. So that is, tan phi is tan 30 degree, which is equal to XC value and XL value we don't know. So we can substitute that and get the answer. XC is 1 by C omega, XL is L omega, divided by R value is 100. So here omega is 2 pi f. Tan 30 degree is 0.5. Or 0.57 also you can write. That is equal to 100. I can multiply this side. 100. That is equal to 1 divided by C omega minus L omega. Here L value is there, omega value is also there. You can cross multiply this. So 50, actually 57 will come if you take 0.57. So that is equal to 1 by C into omega is 2 pi f minus L into 2 pi f. If you substitute the values of L, 2 pi f here, you will get the C value. So finally C value will be around 15.38 microfarad. So try to substitute this and try solving it yourself. So if you take tan 30 as 0.5, you will get this answer. If you take 0.57, actually 57 is the correct answer. So if you substitute 57, what answer do you get? So check that also. So I'm going to give one question as homework here. Take the screenshot and try to solve it yourself. One more question. Okay, so this is also a homework question. Let us solve this question. So here we have obtain the resonant frequency of LCR circuit with a pure inductor of inductance 5 Henry, right? So L is equal to 5 Henry. Capacitor of capacitance 20 microfarad. And a resistance of resistor of resistance 40 ohm. We need to find out quality factor. Q is equal to how much? Q factor. And bandwidth, I will write it as BW question mark. And impedance at the resonance condition is how much? So here first is resonant frequency. Let us find that. That is given by 1 divided by 2 pi square root of LC, that is equal to 1 divided by 2 into 3.14 into square root of L is given, that is 5, into C is 20 into 10 to the power minus 6. So we will get this somewhere around 15.9, I think, yeah, 15.92 hertz. Yeah, you can calculate this, you will get this as the answer. Second thing, we need to find out quality factor. So Q factor formula is 1 divided by R square root of L by C. So 1 divided by R is 40 ohms, L is 5 Henry, divided by C is 20 into 10 to the power minus 6. That is equal to 12.5. There is no unit for this, the quality factor. Next we need to find out bandwidth. Bandwidth is given by resonant frequency divided by quality factor. That is, resonant frequency is 15.92. Quality factor is 12.5. That is 1.27 hertz. And the last one is impedance at resonance condition is R. Therefore, R value is 40 ohms. So this is the answer. Okay, so this is about this video, dear students. We'll meet you in the next video with a few more questions. Till then, take care. Bye bye. Thank you.